What's the driver's name?
Gunzler, Horst Gunzler, born 1950. Why are we covering this accident, Chief? I mean, no one's been hurt, just a lorry that's lost its load, that's all.
You've no idea what happens to loads every day. Most of the time with loads hidden under tarpaulins and van bodies. Any time, one of these lorries might be driving alongside you and then bang, part of its load flies through your windscreen. No one's reckoned with it. And yet accidents happen daily. And it might hit anyone.
Like just now.
Like just now.
Hello, BGF.
Hello.
Where can we find the driver?
He's the guy with the check waistcoat over there by his lorry.
Thanks. It's not true.
Hello. Are you Horst Gunzler?
Yeah.
My name's Rainer Bennett, and he's my colleague Hans Vollin. We're from Accident Research in Frankfurt.
Damn, I don't know how it happened, honest I don't. I can't believe it. I never thought the likes of this would happen to me.
Millions of tons of goods on our roads every day, transported by hundreds of thousands of HGVs every day. Millions of starting, braking, cornering maneuvers. Whoever could reckon with something untoward happening?
Okay, I'll take charge of that. Did you sustain any injuries?
No, fortunately not.
Did you have any first aid treatment?
There was no need. I'm not under shock or anything. Except, looking at this shambles, I just can't understand it. It's impossible. I just can't think how it happened.
Yeah, that's what we're here for. To find out what went wrong with your help.
Do you think you can help us? Tell us what you know.
I think so.
Can you recall the last minute before the accident?
Yeah, everything. Over and over again, like in a film. Yeah, well, I wasn't in a hurry and was driving quite normally. I just left the city centre southbound. I was driving along the village main street quite comfortably, nothing in front of me, because at the next set of lights I'd be first off. Then I got to this slight bend to the right and there was a vehicle parked at the curb. I took my foot off the gas and was about to pass it when suddenly its offside door opened. I pulled out and thought I'd winged him. And the next thing I saw this white Golf heading straight for me at speed. Pulled in sharply to avoid a collision and was heading straight for a parked car, so I slammed on the brakes full power and oh my God! I see the whole load skidding past me off the platform, a direct hit on the BMW. I think, oh my God! And it goes boom, and then it catches fire. I jump out and run back to get the fire extinguisher. Luckily I have one on board. But that little puff of powder, hardly had any effect at all. The car was already burning like anything.
And there wasn't anyone in the car?
No, thank God. There wasn't, fortunately. The lady who owned the car had just left to visit somebody in that house over there.
I see.
It was bad enough as it was. But if there'd been anybody inside...
Tell me, who was the consignee of the load?
Yeah, that's the joke. Those are faulty concrete castings. Nothing but scrap. I was taking them to the construction site of the new M64 for grinding up as road bedding. But I've taken care of that myself now. Each of these sections weighs at least 2 tons. So they were really heavy. And now you tell me, how can they just slide off the platform like cardboard? Damn it!
Every piece and every type of load is subject to forces during transport. These apparently invisible forces exerted on the load cause it to move. But these forces are produced by us in the first place as we drive our goods vehicles. Any type of maneuver can cause load shifting, or any change of direction, such as cornering. During all these movements, the load takes on a life of its own, and its inertia tries to prevent it from adapting to new directions of movement, preferring to keep to the original one. The forces tugging at the load and moving it about are the result of various types of acceleration. This accelerating power is always applied in opposition to the new direction of travel. The load mass. Mass is what the load weighs. What the load presses on the platform in accordance with its weight is also a force, the force of gravity. The official unit of measurement for force is the Newton. What you describe in kilograms of weight is, from the point of view of force, expressed in decanewtons. 30,000 familiar kilograms are roughly equivalent to 30,000 decanewtons, DAN for short.
Just look at this whopper. It would take more than 4 men to move it. With that weight, it should stick to the platform.
No, nothing sticks to the platform.
That's how it often seems. But again, it's a force that creates this illusion, the force of friction. It always resists any attempt to shift an object. Just how long the object is able to resist the movement is expressed by the coefficient of friction. The symbol for the friction factor is the Greek letter mu. Its magnitudes are of crucial importance when dealing with loads. The mu values are derived from the two material interfaces involved in making up the load, and anything that facilitates sliding between these materials, such as smooth surfaces, water, sand or oil, determines this value. The smaller the mu value, the lower the friction factor that keeps the load on the platform. But when does a load start to slide? Provided the load is not additionally secured during the journey, it is only the force of friction that holds it on the platform. But not for long. As the vehicle is maneuvered, forces tug at our load in various directions. If the mu value is exceeded by these forces, the load starts to move. This cannot be prevented by adding more mass to the load. Loads with the same friction factor start to slide simultaneously, irrespective of their individual mass. But what maximum forces are exerted on a load at all? When driving off, the accelerative forces due to high engine power or abrupt gear shifting can be extremely strong. So strong, in fact, that they may equal half of the load's weight, 50%. When cornering, it's centrifugal force that acts on the load. The trouble about centrifugal force is that it increases drastically with increased driving speed. That's why forces are exerted on both sides, which may equal 50 load weight %. The forward-acting forces applied on the load by full emergency braking are the highest. But irrespective of the speed of travel when braking, the strongest deceleration forces are exerted shortly before the vehicle comes to a standstill. Not until this point, at almost zero speed, does the load shoot forward. An enormous burst of energy. Almost the entire load weight percentage is exerted forwards, 80%, a major problem factor.
Excuse me, the recovery vehicle's arrived and we want to clear up the mess. Can you come to the equipment tender with us?
Okay, lead the way. Come on. By the way, Mr. Gunsler, was the load actually secured?
Ah, so you think I didn't lash the load, eh? I don't blame you in view of this mess. But you're on the wrong track. The load was secured. And anyway, I know the regulations for load lashing, and that's exactly how I did it this morning.
You see, I want to know what caused you to drop your load unintentionally. This time, luckily, no one was hurt, but you never know. Next time, the same thing may happen to another lorry. Somebody at the wrong place, the wrong time, and zap. You wouldn't want that, and neither would I. And that's why it's so important to ferret out the minutest details. Who knows? Maybe it was just a little fault that could be eliminated elsewhere. You said everything went according to plan this morning.
Yeah, well, the assignment was quite clear. Taking faulty castings to the M64 construction site for shredding. As usual, I drove straight to the stockyard. Oh, by the way, it's quite clear that my truck is the right one for the job. The plan was to load 21 tons. I checked everything with my loading foreman. He's familiar with the payload and axle load specifications of my truck. You see, I'm a regular customer there. He always tries to place the load centre lengthwise on the platform, same as he did this morning. After we talked it over, I went off to the office to clear the papers. Morning all. Have you got the papers for trip 27?
And in the meantime, he carried on loading?
Of course. The foreman knows his job inside out. I can trust him blindfold. What's wrong with that?
You've got to drive the lorry, not the foreman.
Of course, but he knows his stuff. And he knows the weight of the load. And anyway, I didn't drive off without checking they'd done the job properly again. Now, look here a minute. As soon as I left the office, I checked everything once more, and the only thing I noticed was the shaft ring sections. They were stacked a bit high.
How high?
Well, about 2 to 2.5 meters. Quite a bit above the sideboards. That had to be specially secured, of course, because of the high center of gravity.
Secured? How?
With a lashing strap. Yeah, with a standard lashing strap with a ratchet. I threw it over the rings, and with a hook, I braced it under the sideboard to the strap.
You mean you lashed the rings with a single strap? Why didn't you lash the other sections?
Because the rings were the only parts with such a high center of gravity. Everything else was foursquare on the platform. And anyway, there were the sideboards.
Was that an adequate safeguard, do you think, Mr. Gunzler?
There are safeguarding measures which ensure that the load remains securely on the platform. One common method is diagonal lashing. Lashings are loosely pretensioned in all directions away from the load. Only when the load tries to slide is it held in place by the lashings. This is a positive locking procedure. The load is prevented from shifting only by means of lashings. Another positive locking method is direct load fixation. The load is fixed to the superstructure or chocked with special fittings. There's a broad scope of options here. Load security in road traffic is becoming increasingly crucial, not only from the point of view of public safety, but also to protect valuable cargoes. However, loads mustn't only be safeguarded because they are costly, but also because even the heaviest load can easily slip. Often there's a lack of lashing points on the load itself, as here, or it can't be fastened adequately. That's why one of the most frequent safeguarding methods is non-positive lashing down. Lashing down implies that by pressing down on the load alone, the friction factor is increased so that it prevents the load from slipping.
This was the strap you lashed the rings down with, eh?
Yeah? Well?
Well, wasn't it the right size? Strong enough? Maybe too old? Or was it something else that caused it to rupture?
Yeah, well, if you ask me, I think it broke when the load fell off.
But that's just what it was supposed to prevent, right?
Lashings can only hold up to their breaking point. But the crucial factor is how they are applied. A lashing's real safety potential depends on how it is secured. Every suitable lashing strap must be labeled with its maximum permissible tensile strength. When a load is lashed down, it is pressed against the loading surface with high initial tension and held in place by friction. The necessary force is applied by pre-tensioning it with the ratchet. But the ratchet can only attain a limited degree of pre-tensioning. This force has nothing to do with the tensile strength indicated on the label. Under optimum conditions, this strap could hold 2.5 tons, but with the ratchet, you can only achieve pre-tensioning of up to 400 decanewtons. Creating the force required to hold the load by friction needs other pre-tensioning elements, like this ergo ratchet with a longer tension lever, which can create much higher pre-tensioning forces. If this isn't feasible, the number of straps just has to be increased. There are, however, easier ways of increasing the necessary friction. Anti-slip mats strongly increase the friction factor between the load and the loading surface. Irrespective of the interacting materials, anti-slip mats raise the coefficient of friction. The effect is so strong that considerably less lashing material is required. Lashing down demands equal tension on either side. This is very often distributed unequally when the straps are positioned. The pre-tensioning force exerted on the side with the ratchet is not matched in the least on the opposite side. This deficit can be remedied by very simple measures. Various types of edge guides can be used, not only to protect the strap and the load, but also to ensure even tensioning of the lashing strap. When lashings are applied at an unfavorable angle to the load, they lose their safety value. Either stronger lashings have to be used, or the number of lashings has to be increased. To make it easier to assess the angle and work out the force, you can use a simple goniometer and conversion tables. You can tell at a glance whether the lashing power is sufficient. But what use is the best lashing if it can't be properly secured to the vehicle? Since 1993, all flatbed commercial vehicles must be equipped with fixed anchor points ex-factory. And older vehicles can be retrofitted. These anchor points on the loading surface enable state-of-the-art lashings to be applied quickly and flexibly. New developments in anchor point systems also ensure a competitive advantage by making the entire loading surface available for loads. The load can be conveniently lashed even when the side and tailboards are up. These hooks can also stand up to powerful loading forces and are simply latched onto special frame side rails, enabling loads to be positioned right up to the sideboards. Safeguarding measures can be combined. Here is a combination of positive and non-positive load securing. This method of slip prevention can hardly be improved upon.
There seemed to have been problems before this accident happened.
What makes you think that?
Here. That's a very recent scuff. Did you graze the tyre somewhere?
What if I did? Is that relevant?
It could very well be.
Well, it was like this. I had to turn left at a T-junction, and an oncoming driver was kind enough to let me pass, but he stopped too far into the crossing, so I had to go hard on the left lock, and, well, of course, my trailer rode up a bit over the traffic island curb. There was a bit of a rumble from behind, and I thought, oh, better have a look. So I took the next opportunity to pull in and check the load. I got out and went to check the tyres first. Well, as you see. And then I did the rounds and had a look at the platform. Everything was in its appointed place. I even checked the strap. It was in position and properly tensioned. Absolutely correctly tensioned. So what's wrong?
Every day, goods vehicles are loaded and their loads secured like this. Load safeguarding all too often rests on false assumptions in the hope that nothing serious will happen. But it's not just a chain of unfortunate circumstances when some incident does occur. It is faulty load safeguarding. Loads don't safeguard themselves. With millions of journeys every day, correct load securing is not only an insurance for the driver, but also for every other road user.
Did you shoot a second videotape for him?
As you said, boss.
Good.
But why? What's he need a copy for?
So he never forgets today. Let's go.
If you're interested in further information on load safeguarding, your occupational safety agency can supply you with specialist publications.